goal today, yes, thank you. My goal today is really to answer your question. Okay, so I have a short presentation. Professor Gomez is a short presentation, as well as Isabel Blanco and Professor Zodi. However, I really will leave time for all the questions that you have. So feel free in the second part of this session to turn on your video and ask us questions. So let me start sharing my presentation here. Okay. Okay, so I have a very short intro. I'll tell you about the program, tell you about Berkeley, where you're coming. Some of you are already on campus, some will come later. So what you will expect will be very short, a message. Then I'll have Professor Zodi and Gomez talk about their concentration areas. I've selected 2 concentration areas. There are many more. We have 9 concentration areas. In controls and in mechanics. Isabel Blanco, Mrs. Blanco will tell you about degree requirements, which should be done with items 1, 2, and 3 in 30 minutes. And then we have 20 minutes for Q&A. Let me start about Berkeley. You have been admitted. You are MEng damage program. It's a program offered by the University of California. It's a relatively new university, 1800s. Okay, just to give an idea, I am currently in Italy. One of the oldest university in the world is one from which is 1,800 years before. But most importantly, what is unique about Berkeley is this message that you see in green: the idea that a public university that serve equally children of immigrants and settlers, landowners, and industrial guards. So this idea of inclusivity is key to our values to UC Berkeley. You are in the top university. You'll be in the top university, one of the top universities of the world. We have had 107 Nobel Prizes. 22 are you see them around on campus. You see. Let me see if I can put my marker here. Here's my mouse. Okay. So in the past 3 years, so from 2020, we have had 5. You probably have heard about Jennifer Doudna. There's about CRISPR, and there's a Netflix special on her. We have really, at Berkeley, you can think of Berkeley as the campus itself. That's where we take classes. We have Richmond Field Station. Some of the capstone project might be carried on at Richmond Field Station, especially if they have to do with vehicles, with earthquakes. And we also are very close to one of the top one of the top labs in the country, the Lawrence Berkeley National Labs. You take any ranking, we are a world ranking number 3, number 2. You might it doesn't matter which year, we are always at the top. Okay, and this is the news from last for a few months ago, that Berkeley was ranked as the top public university again by Forbes, and second all over the United States. This is your location here in a map. Okay, Silicon Valley is 20 miles away. You can, Stanford is down here. All the companies heard about, Google and Facebook, they're all in this area. You can go to San Francisco in 10 miles and get a self-driving ride from Uber. They have already 200 cars driving in the city. And have beautiful hikes in Napa Valley and East Bay Hills. I have been, I'm Italian. Every time I present this, I was one of the initiator of the MEng control concentration areas. And I always say, I've been for 5 years, I'm Italian. There's really only one place I want to live outside, and that's really the Bay Area. After you study, you can go and visit Tahoe and ski there. You can actually see the beauty of Yosemite and the natural wonders of California. So let's go back to the program. We have really, Isabel is going to go in details of the MEng program. We really have 3 main cores. We have a core leadership curriculum, which is composed of 8 units. We have a technical specialty, which has 12 units. These are the ones that you're going to take in the MEng in the mechanical engineering department. And then you have a capstone project of 5 units. I'm going to tell you more about capstone project examples and a little bit about the history of this capstone project. Very exciting, and it's really what gives a value to the whole program. We have here Professor Zodi and Gomez, and I don't want to waste their time. We have 9 concentration areas: advanced energy technology, aerospace engineering, biomechanics, control of robotics and automation systems, fluid and ocean, MEMS nano, mechanics and dynamics, model and simulation, advanced manufacturing process, and product design. So what I'll do, before giving an overview, I'll let Professor Zodi start and tell about this concentration area, which is mechanics and dynamics. But really is, first of all, yes, Asim, he was at the start of this program, and is really as capstone project that actually go across all the areas here, from biomechanics to energy and aerospace and fluids. So Professor Zodi, do you wanna, I'll stop sharing. Do you wanna tell us a little bit more about your concentration areas, your view on the program? I'll stop sharing.
Thank you, Francesco. So,
and thank you for doing this. We really appreciate it.
No problem. So are you guys, can you see my screen with something called Industrial Capstones in 2022? So yeah, I primarily supervise industrial capstones with companies. In fact, oftentimes you won't see my name until the very end because we try to highlight the company name. These were some of the companies last year. There were 8 that I supervised, and they range from Shelton AI, which was financial forecasting using large-scale AI and neural nets. That's for short-term predictions of market in time series analyses. It ranges from Space Kinetic, which was a company that works on energy-efficient lunar payload transfer. So basically, that's shooting stuff from across the surface of the moon in an energy-efficient way, using what little solar power one might have during certain periods of time. Blue Endeavors, which developed deep underwater iPads, basically for underwater sea life. So how you encase an iPad and take a normal standard device and then encase it in a construction so that it doesn't crack and doesn't leak and so forth. Sports Athletic with Cal Athletics, that was primarily to work on learning enhancement and performance kinematics. That was done jointly with Samuel Merritt University. Neuralines, which was using drones for sniffing leaks and leak detection in large-scale industrial facilities. Siemens Direct Air Capture, which is at the Richmond Field Station, which is primarily, as the word indicates, to try to sequester carbon and use it in an appropriate way that it can't escape again. In this case, we were thinking about using this for inside concrete and embedding the recaptured carbon in concrete. Quick Cart was for automated industrial shopping, because I think we've all been maybe to some place like Home Depot, where we have maybe a contractor that buys a large amount of stuff and it takes a large amount of time. It wastes that person's time because they need to go quickly to a construction site. It wastes the normal people's time. So we were trying to figure out automated ways just to allow people that are in construction to go in and out of these locations so that everybody has their time saved. And finally, Hair Robotics, which is an automated haircut type of device, which did automatic braiding and cutting with robots. So they range the gamut, but there's a common theme in all of this. And the common theme is modeling and simulation for industrial research applications. And primarily what we're really keenly interested in is the concept of a digital twin. So digital twin is a digital replica of some type of physical system that runs faster or in real time, at least, with a device in the field. And the idea is that this digital replica or avatar can predict faults, can predict optimal choices that the machine or the device or the physical system needs to make before it actually happens, so that we can determine whether we can circumvent any kind of problem that might occur in the future. So the typical thing, and I think here's a good example, is a problem of an industrial research application with a robot. And let me just first skip the YouTube video and let me turn the volume down a bit in this thing. So just give me one moment to put the settings right. So the idea here is that, this device is a large-scale industrial titanium printer. Its primary interest is to take STL files from a 3D printer, then convert that into machine language, and then to use that to basically control the device in real time. The interest here is in additive manufacturing, there's a large amount of interest in that area, but it goes a bit further than the standard thing that we usually are interested in, which is essentially dropping the powder onto a target. In this case, it's powdered titanium, where the target is actually fusing the material at the same time with the laser. Now, the key here is that this is a complicated multi-physics problem. There's a large amount of kinematics and dynamics, heat transfer, physics, and so forth. And the device itself has to go through a lot of different machinations. It not only takes into account, the depositing of the material, it also brings the material to machine tolerance levels by essentially subtracting. So this is a super complicated multi-stage process, which we need some type of digital guidance. And the digital guidance in this case is given by a digital twin. Now, the devices are expensive. They have machine tolerances that have to be met. And if the device screws up, for example, it makes parts that are extremely complicated, impellers, propellers, things of that sort, that if the device is a mistake, meaning that the final product is a mistake, it's $100,000 to $200,000. So it's a very costly mistake that someone might make. So this was the motivation years ago when a lot of these digital twins started. And there's a large number of companies that have funded this work, at least in my group, for a number of years. The primary thing is this simple flow chart, which is essentially you have computer models with adjustable parameters. You run a simulation and you hope it matches some kind of desired response, meaning it's either a response that someone measured in the field or a response that you aspire the physical system to attain, and you compute the error between what you simulated and what you got for a guess of what these adjustable parameters are. And we're talking about thousands of parameters: the feed rate of the material, the laser strength, the type of material, the environment around it. There's many things that you could adjust. So unless you're a great guesser, you're never going to get the desired response in the first time. You check the error between the simulated response and the desired response using your favorite metric, L2, H1, L infinity, whatever metric you like. You adjust the parameters and you rerun the model again. Now, this is what we've always done with simulations. It's just that within the last 10 years, the speed at which we can do this and the feedback mechanism in how fast we can readjust and home in on the correct parameters has now taken, a life of its own. It's extremely fast. So for example, a simulation that I wrote for a laser hitting that powdered titanium on the target, and what you're seeing there is the irradiance or the strength of the laser as it hits, reflects, and the amount of energy that's absorbed is now a split-second calculation. So this is something that is so fast that it's essentially faster than the actual device itself and can be used for predictive reasons. Now, this obviously has extensions well beyond manufacturing. You can use this, of course, for training robots, which is the first thing that people attempted to do in industrial settings. But it's also that you can use this to design types of different fluids, strengths of the lasers, as I said, finite element methods to basically determine strength of, or the compliance of the material, whether it'll crack, automated aircraft planning. So for example, we've worked a lot with CAL FIRE, which is essentially to dump material onto a target and try to determine what the optimal strategies are for a pilot to hit the targets. In this case, hitting the targets are blue. And in this case, what the targets are, they basically are little fires in a target zone that were taken by a photograph from a satellite. The idea is that, the updraft of the heat, which is governed by the governing mechanics equations of the Navier-Stokes equations, have a tendency to have buoyancy. So basically they blow the air upwards. In many cases, these are hurricane level winds. And so, of course, if the target isn't hit properly, the pilot has wasted their money, essentially with the amount of material that is hit the target, and at the same time puts themselves at risk. So we run these simulations backwards and forwards over and over again in a split second before the pilot ever gets into the location where they need to do it, and we optimize their strategies. Now, there are many other possibilities. For a number of years, we had COVID-19 pandemic MEngs where we optimized ventilation systems. If someone coughs in an industrial setting, for example, a clean room, how do we turn on the vents in such a way to sequester the particles? The optimal design of explosives, that was a number of years ago for the Army research labs, multi-air vehicles and how they in teams work to go after a target, power grid control, where we basically determine how much energy is transmitted back and forth between several entities, ballistic air shields, so basically used for aircraft. In this case, this is a rotor burst that occurred in a 747, how those fragments actually hit the targets, whether we can optimize and harden the hull in such a way that it doesn't have as many possibilities to hit. In this case, we're showing the size of the material that actually has been taken out by a fuselage exploding, optimal configurations of solar panels, heat control in data centers, vaccine design for next generation, COVID vaccines. And of course, COVID seems to be making a comeback. Asteroids, so basically how we detect and determine how much energy is needed to take an asteroid and push it out of the target. In fact, 3 weeks ago, we had a scare. A asteroid the size of a skyscraper barely missed Earth by almost only a quarter of the distance from the moon, because we're completely blind to asteroids that come from the sun side. So this has become an extremely hot topic now, is to determine exactly how much energy is needed to nudge an incoming asteroid and whether we can do that in time. The main theme, again, just in closing, is all of these have one thing in common: differential equations. In fact, differential algebraic equations with constraints. So we have to learn some numerical methods. We adjust the parameters. We try to make the parameters in the system match our desired response. We control the error by adjusting the parameters. And one way to do that, which is popular among many students, is to use genomic machine learning, which essentially means that we encode the entire system as a piece of computational DNA. We then go through the processes of evolutionary computing, which means that we test the DNA of the system. The DNA represents all of the key physical parameters in the model. We then keep adjusting the parameters in the model in a systematic way. The way we do that is essentially we take a genetic population of many random guesses of what we think are the best configurations or parameter settings. We run them through the digital twin, which means it goes through very quickly all of these calculations. So we have to be good coders. We then have to rank the population of these genes. We keep the best ones. We throw away the worst ones. We go through some combinatorial optimization of combining these genetic strings. We produce 2 children, 3 children, 5 children from each of the good performing parents. We eliminate the weak genes. We put the new genes and we ask them to compete against what we've had before that were good. And we repeat the process over and over again. This is a form of non-convex optimization using non-derivative search techniques. So in closing, if you're interested in the types of projects I work on, please contact me. Also have a lookout for the industrial capstones. In many cases, again, it's not listed who's the advisor, but we welcome you to try to make that selection. So back to you, Francesco.
Thank you so much, Professor Zodi. And before you leave, we are on a tight schedule, but if there is one question, maybe for Professor Zodi, he can take it now. Otherwise, we'll take questions towards the end of this presentation.
I'm happy to stay on, so I can wait till later.
Okay.
No problem.
Okay, good. No questions for now. Let's go. Just doing a time check. Professor Gaucher-Lamberts and then Professor Gomez, if you can, 5-8 minutes each, and then Professor Mrs. Blanco is gonna go next.
Okay, great. So Francesco, you want me to go now?
Yes, go ahead. a
Okay.
few minutes about your area, concentration areas, what excites you, why should they pick a project in your area?
Great. Okay, 1 second. Let me just share my screen. Okay, are those displaying? Okay.
Yeah, yes, great.
All right, great. Hi, everyone. So my name is Kosa Gaucho-Lambert. I'm faculty in mechanical engineering, and I'm the advisor for the product design concentration. So I think we have a number of you in product design this year, about 40. So I'll just give you a quick overview of some of the courses and as well as a few capstone examples. So the product design area is quite broad, and the overall objective here is we want to introduce you to some of the foundational technical skills and integrated design methodologies to help you develop cutting-edge product services and systems. And so one class in particular that I want to highlight is a course that I teach on human-centered design. And before I do that, I just really want to mention, because I think, the MEng program goes so fast, people forget all of the, incredible spaces that you have available to you to involve yourself in making and prototyping and designing. So in addition to the Echeverry machine shop that's in the mechanical engineering building, you also can have access to the Jacobs Hall Makerspace. So that's the building shown here on the right-hand side of the slide. And there's a vast array of rapid prototyping facilities that are available there, as well as the Citrus Invention Lab, which is another makerspace on campus, and much more. So please come in, talk to me if you have questions about some of these different spaces, and I'd be happy to get you set up so you can actually use them while you're on campus. So one class that I teach, and I just looked at the enrollment, and yeah, a lot of you are on the list, is human-centered design. So this is almost like a capstone type experience class. Everyone will be put into teams of about 4 or 5 students and progress through a 4-stage design process that begins with identifying opportunities, conducting design research and understanding their problem, then developing solutions, and then prototyping that solution and bringing it to life. So you'll be either working on a project that's proposed from you, so your classmates or yourself, and we also have a variety of industry projects as well for you to work on. So I'm not going to go into depth here, but we've had some really exciting projects over the years. I'll paste a copy of these slides in the chat once I'm done talking, but you can also browse some of the prior years' outcomes and project pages just to get a sense of the type of work that goes on in the class. Okay, and in terms of MEng projects, the capstone projects, so I'm just going to give a snapshot really briefly of some of the ones that I've offered over the years. Most of them, and again this year, are in collaboration with Autodesk Research. And so with Autodesk, we're really interested in kind of these, what we call next generation design systems, most of them using generative design algorithms to aid in the design process. So this involves inputting a set of constraints or parameters, using algorithms to automatically generate, hundreds of thousands of designs that satisfy the set constraints, and then, browsing, exploring these examples, and eventually prototyping them and exploring them further. And so along with this comes a lot of open questions. And so these top 3 projects are all have to do with this process of next generation design systems. So for one of them, we're interested in using augmented and virtual reality to explore some of those different design alternatives. So that's a really exciting question and something that Autodesk is super invested in. The next is around natural language processing and prompt engineering, and how that, the way that we express the intent and what we would like to see these systems generate, how that actually impacts the returned results. And then a last one that has to do with visual creativity. How can we actually get the type of visual designs that we're hoping to see, not just ones that are satisfying some of the functional requirements. And then finally, I have a project related to how we measure trust or confidence in human-machine interactions. So I think a lot of exciting projects. Would love to talk to folks further if they have questions. I know we're on a tight time schedule, so I won't take up any more time. So if you have any questions for me, please just send me a message in the chat now. I'll stay on for a few minutes, and you can also contact me at these details shown on the slide. Okay, that's all I wanted to cover today. So thanks.
Thank you so much, Kosa, for making the time to be here today. Thank you. I know everybody has a very busy schedule. Professor Gomez, you are next. We cannot hear you.
Hello, everybody. Good morning and welcome to Berkeley. I'm Gabriel Gomez. I'm a lecturer here at the ME department. And just like the others, I'm going to go through a sample of the projects that we're offering for capstone projects. Excuse me. There are a few here. For all of them, I am the instructor of record. For these first ones, I act as the faculty liaison. So these are projects which are offered by our industry partners or by other institutes, some at UCSF. And these last three are ones where I will directly supervise. So I will be the advisor as well as the instructor of record. I'll go through them quickly since I know that we don't have much time. Actually, I'll go through them here. These first four are being offered by Blue Goji, which is a company that is developing solutions for wellness and recovery and rehabilitation using gamification. So VR is one of the main technologies that they use. They've done several projects already with us over the years, and this one last year called the Omni, this is a picture here of the prototype that we created and that is now sitting at Hesse Hall, is a 2D treadmill. So really cool. The students last year put this whole thing together, which was amazing. And the project this year on the omnidirectional treadmill, there are two, and numbers 32 and 42, they are about now developing the control system, because as it sits now, this is fully manually controlled. And it's quite tricky because you can imagine that in its current state, nobody can get on it. So we have to do this in simulation. So it's, but also the simulation acting with the hardware in the loop. It's pretty challenging. And for those two projects, the info session is today at 4 p.m. So I encourage you to go see that if you're interested. In general, I'd advise you, if you're interested in any of these projects, to watch the videos where they'll give much better explanations than I'm doing here. Another project with Blue Goji is studying the effects of pedaling at different cadences on attention using EEG recording. So that's really neat. They have designed an in-ear EEG sensor. So it's sensing brain waves. And the reason that's cool is that you can use it while on the treadmill or on a stationary bicycle or something like that. The third one, developing Forenz as a rehabilitation, encouragement, and facilitation tool. This is more a VR project, a virtual reality project, where instead of having a physical therapist, you have a little VR dog that is giving you feedback and encouraging you to get up and get moving according to some plan for whatever rehab you're doing. So these are really cool projects. I'll just mention that for the EEG project, info session is PM here at 5 p.m. And unfortunately, the info session for 74 was yesterday. So maybe you already caught it. Evolution Devices, this is another long-term partner of ours. They're a really cool company, startup here in Berkeley, and their focus is on a wearable device that it corrects a particular disability called foot drop, where a person tends to drag a foot as they walk. This year, they are actually developing a new system for capturing 3D motions. You know, this is usually done as in Hollywood with lots of little sensors placed all over the body or these little ping pong balls, but they're doing it with none of that, just with cameras and creating these wireframe movements. So they are a really active, small and smart company here in the Bay Area, in Berkeley, actually. This is a new partner of ours, JD Margolisi. He's an entrepreneur here in the Bay Area. He has a long history with Berkeley and has founded several companies in the IoT space. And now he's starting a new endeavor, which he really believes in passionately. And it's about creating a software architecture for system integration. So if you're interested in how IoT systems talk to each other, he has developed the software foundation and is now going to use it to create a demo. And I think this is a great opportunity if you are interested in seeing an entrepreneur with a lot of experience in creating companies, do it from scratch and learn a lot from JD. Now there are a couple from UCSF, and these are focused more on the application of machine learning in the medical context. So Edilberto Amorim, he heads the Amorim Lab, and he has 3 projects. They're all on the topic of using EEG waves, but also other sources of data, integrating them through machine learning to predict or know more about patients in a state of coma and how to treat them and how to predict what treatments are working and when they might wake up. So he did this, he did a project last year, which was super successful. Also from UCSF in a similar context is Madhumita Sushil. She is more in the area of NLP and text processing. And so she is taking data from medical records and other sources of information and trying to put that together to assist doctors in understanding the situation of patients quickly. She actually also started last year, and she won the prize, a prize from the Fung Institute for best capstone project. So she's a really great advisor. I haven't been saying what days are the info sessions. I'll go through that really quickly at the end. And then the 3 that I am offering, these are the machine learning workshop. If you're interested in, if you don't know much about machine learning or you know a lot about machine learning and you're interested in delving deeper, I think this is a good one. We get together weekly to talk about machine learning. Everybody's working on different projects. Sometimes people within the group pair up and work on something. And by the end, we have solved a whole bunch of problems in machine learning and learned a lot. The Controller JetBot is this is a very simple and easy to use sort of DIY environment for control, for testing control algorithms and reinforcement learning algorithms that you may be learning in your courses. We have a lot of fun with these little cars. And then AI for traffic, we use traffic simulators, open source traffic simulators, to develop control algorithms and reinforcement control algorithms to manage vehicular traffic either at a local level or at a system-wide level. So if you're into that sort of thing, look into AI for traffic. My info session will be later today at 4 p.m. I realized that all of these projects have Python as a basic coding language. And many of you may know Python already and would like to brush up, and some of you have no Python experience. And so as part of the ramp up, what I offer to the students in any of these projects that I have mentioned, a free mini course. By free, I mean you're free to take it or not. And we do it over 10 hours, about 10 hours over Zoom and over maybe 5 days. It's very informal, it's optional, no grades associated with this. We'll do it around mid to late September. And this will help you to, one, set up your development environment in Python using Jupyter notebooks and or more advanced IDE like VS Code, learn basic elements of the language. So I'll go through all of the syntax and all of the basic programming, and also the more advanced and fundamental packages that you'll need to use in your project, such as NumPy, Matplotlib, Pandas, and others. And we can cover as needed. But this is
Gabriela, there is a question for you here regarding this, that if we are not in one of your capstone projects from Austin, can we still attend your Python workshop?
That's a good question. And the answer is no. I keep it for the people in these projects, just to keep it manageable, really. Yeah, okay. But thanks for the question. That's about all I have to say. Thanks a lot. If you have questions, I'll take them later or now, but also I'll have the info session later today. Thank you very much.
Yeah, thank you, Gabriel. We are running really short of time. Isabel, you're next. Again, for everybody, you're gonna see us around for the whole fall semester and spring, and this is really a welcome. And then to show a little bit the depth, the amazing, really depth and breadth of this program. Okay, I have been traveling for the whole summer, visiting universities, and honestly, I haven't seen really the complexity of these projects that go deep down from study, simulation to implementation, the breadth. You could go from 9 concentration areas, really any topic you are interested in is covered by our program. Isabel is gonna do a deep dive a little bit on the, I know that you probably have already, if you had questions, probably already emailed Isabel, and she had info sessions in the past. But maybe, Isabel, you wanna remind everybody the program structures and the requirement?
Yes, Professor, I can do that. Let me just share my screen. I just wanted to welcome everyone to UC Berkeley. I'm Isabel Blanco, and I'm your graduate student advisor for the MEng program. Just wanted to show you, first, just go over the degree requirements. In the Department of Mechanical Engineering, we have our areas of concentration. It's not too late to change your area of concentration, but you should do so before the semester begins, because the classes that you enroll in depend on your area of concentration. So these are listed here, and you should be very familiar with them. There are 25 units you need to do to complete your degree. 12 units must be in the ME 200 level course. 8 units are from the Fung leadership courses, and then 5 units are from your capstone class. Normally it's 2 units in the fall and 3 units in the spring. In addition to the 25 units, you need to complete your leadership comprehensive exam that's taken in the spring, and your technical comprehensive exam that's taken at the end of the spring semester. All courses must be taken for a letter grade, and a minimum of C- or higher needs to have been in your course to complete towards your degree. These are the courses for the fall semester. I've sent this out, and it's also been available on our ME department website. And it's under each area of concentration. Next is your ME department comprehensive technical oral exam. There must be 2 members of your committee sorry. One must be from the ME department and one can be from outside the department. Each individual is tested on the ME content of your capstone project, so it's very important to remember that. And if you select a capstone project in another department, you will still be tested on the ME content of your contribution to the capstone project. You might also be interested in the MEng Tech Plus certificates, and that's on the FUNG website. So in addition to the 12 units of the ME 200 level coursework, you will be requested to take more technical courses depending on which Tech Plus certificate you're interested in. Some of questions are, what if I have back-to-back classes? At Berkeley, we have something called Berkeley time, where instruction actually starts 10 minutes after the start time of your class. So you are given 10 minutes to go from one class to another, which is possible in most cases, as long as you don't have a class that's, for example, on south side of campus, and then you have your next class start on north side. But for most instances, you can walk from one class to another in about 10 minutes. Can I take technical courses outside the ME department? Yes, but they won't count towards your MEng degree. Can I be a GSI TAR reader? Yes, we do have students who are GSIs or TAs or readers. We don't recommend it due to the short length of the program, but you are eligible. Can I extend to a program to a 3rd semester? Usually no, unless there's an extenuating circumstance, and you will have to make that request before we allow you to extend the program to a 3rd semester. Can I add to the PhD program? Yes. We do have some MEng students who continue on to the PhD program. You do not need to submit an application, but it's all done through an internal application, and there is a link here. This is my contact information. We are in Echeverry Hall, 6th floor. I encourage you to stop by, say hello, especially during the beginning of the semester. I am in 6189 Echeverry Hall. I am remotely right now on Mondays and Tuesdays, and on campus Wednesday through Friday, but that may change when the instruction begins, and my Zoom office hours are to be determined. Again, welcome to Berkeley, and go Bears.
Thank
Professor
you. Go
Zodi.
Bears. Thank you very much, Isabel.
You're welcome.
We have 10 minutes for taking questions live. Before that, a couple of minutes going back to the chat. Let me see here. Angela, thank you, Kosa, for answering some of the questions. Maybe this one here. Is Berkeley time also used for boot camp classes?
Not for boot camp, no.
No. So boot camp classes do not use Berkeley time, okay?
Correct.
Then will the boot camp classes be recorded? There's a last change in travel plans. Do you know, Isabel, if they are recorded?
Boot camp classes, is my understanding, they are not recorded, and that you are expected to attend during that specific time, even if it's an online course.
Okay, so that's for Santosh here. So the recommendation to Santosh, if he had a last minute change and we cannot attend boot camp classes.
So please contact the FUNG Institute at funginstitute@berkeley.edu. It's our understanding that you can no longer switch bootcamp sections after August 1st. So please contact them as soon as possible.
Okay, so that's for Santosh Kartilian. Please contact the FUNG Institute because that seems a hard requirement. Angela San got the answer. can a little bit more about the oral exam, what it's used for. I can talk about that. So the exam, you're getting a master from UC Berkeley. So the oral exam is to test your contribution to the to your final master project. Okay, so usually these oral exams are short. You have a part where you describe your project, and a part there are questions on what was one or a few questions on your technical contribution to a specific project. So this is used for actually getting a grade on your final master project. Isabel, is there anything else to add about oral exam?
Yeah, if you have any more questions about the oral exam, you can send me an email.
Okay. Where can you see or change your concentration area? Okay, you already answered to Magnus. Okay, I'm missing a delay, a day of boot campus about visa. Again, Isabel, what is the recommendation for visa issues and boot camp?
So if you are have any delays in your visa, please send us an email so that we can talk about maybe if you have to defer your admission due to visa delays. That unfortunately is getting more common.
Okay, so they should write to Fang and to you, is that correct?
Just to me,
Isabel?
yeah.
Just
to
you.
me,
Okay.
yeah.
Okay. Jerry Chen, will 200 level ME classes outside of concentration count towards the degree requirement?
No. Oh, sorry. Courses outside the area of concentration.
Yes.
As long as it's, yes, as long as you take one course in your area of concentration, we will allow you to take the second course in another area of concentration, as long as it's an ME 200 level course.
So Jerry, for now, there is a one course requirement in your area of concentration only.
Correct.
Are students required to train to use machine shop in Echeverry Hall, or can they use it if they were certified during undergrad at a different school? About machine shop certification, can they use it, or they need a special training, or what if they got a training in a different school?
I believe you still need to go through the machine shop training if you want to work in a machine shop.
Okay. Okay. Okay, I think, do we have a study place in Fang? Is there a study place in Fang Institutes?
Yes. So in the Mud Hall and Shires Hall, they do have meeting rooms, and they actually do have them scheduled for the 270A and B boot camp classes.
So for Changchi, Huang, yes, there are. What are the halls? Could you write in the chat?
Yes. So it's Mud Hall and Shires Hall.
Shires Hall. Again, I see regarding boot campus require live participation. That's from Santosh Kartilen again. And understanding is, yes, you need to be in person at the boot camp. Is that correct, Isabel?
Some of the sections are actually online.
Some of the section online.
Yes.
Okay. So Santosh, please contact Isabel regarding your boot camp question. Credit limits on how many courses we can enroll each semester. Oh, 20.5 units. Okay. Isabel, if you can put your slide on of your days and times you're on campus and office location, can you, so they can take a screenshot of your,
Sure.
that's tentative for now. We are August, semester has not started yet, but okay, here it is. Please take a screenshot of this. Isabel, email, 6th floor on Echeverry Hall. And again, this is tentative. So Isabel, change this. I will inform you if she is gonna change.
Right.
Okay. Very good. Please take a screenshot. Anything I like back. I'm here to shop training. Okay, we still have 5 minutes left. Thank you, Gabrielle, for sharing your slides. Any more slides regarding, any more questions regarding capstones? Again, you are going to win the depth of each capstone. There is a presentation, an info session. There are videos that are recorded for this capstone. This session is again for welcoming you, giving a little bit a glimpse through the project, some of the projects, and looking forward to see you and meeting you on campus. Many Tech Plus courses are not offered this year. Isabel, many Tech Plus courses are not offered this year. Can I ask where the latest course can be found?
So we are still working on the spring 2024 course list. But if you send me an email, I can send you the tentative list.
Okay,
Which
so
will,
the reason why,
yeah.
The reason why this is for Cui Yang, the reason why you don't see them because the list is not completed yet. If you send an email to Isabel, she's gonna send you a tentative list. Okay. Any questions over voice?
You can go ahead and unmute yourself if you want to ask a question.
Isabel, what about fall 2023? Are there any Tech Plus courses for fall?
Yes, they are. Yes, depending on which Tech Plus certificate you're interested in, we do have, if I remember correctly, we have at least one fall course on that list.
There's a question for me. I will not be teaching experiential control this fall. This is correct. I will not be teaching. However, I'll be on campus. I'll be offering capstone projects and I'll come to class time to time. The person teaching, and I'm on a partial industrial leave for a startup on campus. The person is teaching is it's an expert, is a former student of mine that has worked in a company and then is coming back to campus. So you are in great hands regarding experiential control, and you'll still be able to schedule some time to talk to me. I see that Professor Zodi sent you amazing place to see. This is, I've been all of them. I haven't been, let's see. Oh, I haven't been in Moraga. Bird sanctuary, they're all beautiful. Don't forget that you are in the top school and most important, one of the top places to be in the world. Okay, so thank you, Zodi, Professor Zodi. Let's see. I also has a list of favorite restaurants here. Specific staff email we can contact regarding the FUNG Institute, such as boot camp. Is there a okay, fine, perfect. Isabel, thank you for answering that. Going through direct list. I think. I think we need to save the chat. I don't know, there's a way to save the chat for all the restaurant. Okay, we'll save the chat, and so we'll email you the chat so that you have question answer and the restaurant list of Professor Zodi.
Yes, I can actually save the lists from the chats and add it to our ME website.
Perfect.
Make sure to show your Berkeley ID. They give you a discount at all the restaurants.
They do.
Not.
What's your concentration in the system? Is there a way to, for somebody that's forgot their concentration area, is there a way to check in the online what is their concentration area?
It should, if it's not already listed on your Cal Central portal, send me an email and I can look it up.
So this is for Kai. Please check on your Cal portal. If you don't see it, send an email to Isabel. Okay, that's for Angela. From Angela, for CAPS, how much interaction should we expect to get with our faculty advisor, weekly meeting guidance? Is it advisor and team dependent? I think the answer is yes, it is advisor and team independent. I can speak for, I'll speak and then I'll let Gabriel have a comment on this. For instance, I meet with my team once a week for 1 hour. And then there are cases when if there's experimental, they will meet with my graduate students more often. Gabrielle, any comment on this meeting with faculty advisors?
That's also my policy. I meet with them once a week for 1 hour. It's with the industry partners, it will be once a week or once every 2 weeks is my experience, what they offer. And with your faculty advisor or the instructor of record, maybe a few times a semester, once or twice a semester, just to make sure you're in line with what you're doing.
I see the 10 a.m. I do have a sharp 10 a.m. meeting. You're welcome, Angela. I don't know, Isabel, if you can stay a few more minutes, but our time is up. You'll see us on campus. Looking forward to meeting you all, seeing you around, meeting you in classes. Thank you, Professor Zodi, Professor Gomez, Professor Coger-Lambert. Thank you, Mrs. Blanco, for this session. Thank you, everybody, for joining us today.
Thank you, everyone. I will stay for a few more minutes if anyone has any other questions or would just like to talk about their experiences. Thank you very much, professors. Bye-bye.
Bye-bye, everybody.
Bye-bye.